For this video, I'm going to assume that you've seen the basic features of a rational function. I'm going to move through these fairly quickly. If you're still learning that stuff, I recommend going back to one of the other videos, the more intro ones. Right here, let's start with this rational function. You notice there's no factors up top. Okay, so when you have no factors, that means no x-intercepts. So for my x-intercepts, I'm just going to say D and E. There aren't any. For my y-intercepts next, I want to point out something. If I set x equal to 0, right? If I say x equal to 0, that's how you find the y-intercept. Okay, because at x equals 0, look on this line I'm drawing right here. Somewhere at this line, x equals 0, is where the function crosses the y-axis. This is how you find it. So if I set x equal to 0, look what happens. Well, this one goes away, that's 0. This one also 0. All that's left is what? 9/6. So here's my y-intercept. X equals 0, y equals 9/6. And if you want, you can simplify that as 3/2, right? I would. But that's a really quick way, and it's a very useful method of finding the x-intercept if you have the unfactored form. Factored form, just a little tougher to do that, but you can do it from either form, really. Now, with rational functions, almost all the time you're going to have vertical asymptotes. And remember, these are factors on the bottom, these guys right here. So I see those two factors. They're not repeated on the top, so I know it's not a hole in the function. And these are just going to be located at x equals -3 from that first one on the left, and -1 from the factor on the bottom right. And we come to the last key feature of this rational function, which is the end behavior, or the end behavior asymptote. Now, what I want to focus your attention on for this is the weight of this function. So if you look at this guy right here, notice how, I'll say it like this, factors of x are bottom heavy. In other words, there's more of them on the bottom than the top. Okay, I've got x squared on the bottom, no x's on the top. That means there's a horizontal asymptote at y equals 0. No math required. You just have to see that there's a bigger exponent on bottom than top. We're done. Y equals 0. So that's that asymptote. Now let's go ahead and plot all these features on the graph. I've got my, and you know, just to be consistent with some of the computer program problems that you guys do if you're using my homeworks, I'm going to use all asymptotes in red, whether they're horizontal or vertical or whatever. So here's my horizontal asymptote. I have two vertical asymptotes, one at -1, right here, one at -3. I'll put that one right there. And I have one intercept, only one, the y-intercept, at y equals 3/2. I'll just draw it right there. And that's it. That's all we have for this function. So we have to draw the shape of this curve based on this information we have right here. Now, remember, you're supposed to approach the asymptotes as you get towards the ends of this graph. So if you try to think about something like this, see how I'm approaching that asymptote? That looks okay, except what's the problem here? Look, I'm creating an x-intercept where I said before there should not be any x-intercepts. So I know I have to approach the asymptote this way. Hit the y-intercept right there, and then I'm going to glide along this horizontal asymptote out to infinity like that. So there's my end behavior for the right interval of the function. Now let's move on to the middle interval between these two red asymptote vertical lines. If you look at those, you might wonder, well, am I supposed to do this or am I supposed to do this? Don't really know. The way I would look at it is you have odd asymptotic behavior. And here's what I mean. Let's go back to these factors right here. Look at each of these factors. They are odd because they don't have any exponents on them. Or it'd be more appropriate to say the exponents are equal to 1. It's x plus 1 to the 1th power, x plus 3 to the 1th power. So that means it's an odd exponent, they're going to have odd behavior, which means if you're up on one side, you have to be down on the other. So here's what that's going to look like. See, I was up over here, and now I'm down on that side. Even would have been up on both sides or down on both sides. It would have been symmetric. But in this case, I have an odd symmetry, so it goes up and down like this. So I can't cross the x-axis like that. That would be bad, because there are no x-intercepts. So instead, I'm just going to have to continue back down on the other side. And because the vertical asymptote at -3 is also odd, look at its exponent, that means you have to switch, and now you come in from the top. Okay, so in this way, we were able to draw the entire function using not many features. This will get more complicated as we move on and add factors, but I think this is a good intro one.